All right, ladies and gentlemen, we're going to continue our work with ratios and such things. Today we're going to talk about solving proportions. So in the end of this, again, being able to set up and then solve a proportion is what we need to be able to do. So really quickly here, one thing we do need to deal with is the idea of cross products. Okay, the product of numbers on the diagonal when comparing two ratios. In a proportion, cross products are equal, and this is important, because this is the part, and if you've ever heard of cross multiplication, this is sort of what we're getting into. If we have a proportion, the cross products are equal. All right, now let me give you an example here, and I've set up two ratios. It's pretty obvious that 2 over 3, 2 to 3, is equal to 4 to 6. Okay, and I've done this one on purpose, a very simple one, just to illustrate the idea that cross products are equal. So we know that these two fractions, these two ratios are equal. So if I go through my cross products, which means that if I cross multiply, which is not a technical term, but I'll use it for now, 3 times 4 is 12. And if I use my other cross product, going the other way on the diagonal, 2 times 6 is 12. In any proportion, cross products will be equal. So we can use that to our advantage in a couple ways. So first of all, we're going to use cross products to identify if two ratios are proportional or not. So the question here basically is, are these equal right here? Okay, is 5 to 6 equal to 15 to 21? Now you may look at this right now and know automatically at this particular point that yes it is or no it isn't. But let's just go ahead and check. The cross products will be equal if these are proportional. So if I go 5 times 21, that will equal 6 times 15. Okay? And some people call this cross product things the butterfly. That's a very poorly done butterfly, but okay, butterfly. There's yellow antennas and so on. Okay, anyway. So if I multiply here, the cross products should be equal. So 5 times 21, well 5 times 1 is 5. 5 times 2 is 10, 105. Okay. The other way, 6 times 5 is 30. Carry my 3. 6 times 1 is 6. Plus 3 is 9. And so, in this particular case, these are not proportional. Not proportional. Not proportional. Let's see if I can spell it today. P-R-O-P-O-R-T-I-O-N. A-L, not proportional, okay, because the cross products are not equal. Now you could do common denominators and things like that and treat them as fractions and find the same thing, but this is just another way. All right, let's go ahead and do another one. 8 times 9 is 72, and 6 times 12, well 6 times 2 is 12, carry a 1. 6 times 1 is 6, plus 1 is 7. 72 is equal to 72, so these are proportional. P-R-O-P-O-R-T-I-O-N-A-L. Still difficult to write with a mouse. I-O-N-A-L. Okay. So, and again, proportional means equal. So these two ratios are equal to one another. All right, so we're going to go on and we're going to use that information, the idea that we do have proportions to solve actual problems. So, okay, a shade of paint is made by mixing 5 parts yellow paint with 7 parts green paint. Will 21 quarts of green paint and 15 quarts of yellow paint make the correct shade? And in order to see if they will, we will check to see if we have a proportional relationship here. So I'm going to go ahead and let me pull out the important parts here. Let's highlight some things. 5 parts yellow paint with 7 parts green paint. That can be written as a proportion. In this case, I'm just going to put it in order. 5 parts yellow. I'm going to just put a little Y here just so I know that it's yellow. To 7 parts green. Okay, so that's my first ratio. Now it is important here. I'm going to set up a proportion. Well, we're going to check to see if they're proportional anyway. So I'm going to set up a possible proportion. My second ratio, though, I have to go yellow over green. Now if you went green over yellow here, you would have to go green over yellow here. All right. So now we are told that we have 21 quarts green. Okay, so my 21 in this case is going to have to go in the bottom. and we have 15 yellows. 15 yellows. And again, you may look at this right now and automatically know yes or no. I'm just going to go ahead and use my cross products just to check and to verify. All right, so if I go 7 times 15, well, 7 times 5 is 35. Carry a 3, 7 times 1 is 7, plus 3 is 10, 105. So if I cross multiply the other way, use my other cross product, 5 times 1 is 5, 5 times 2 is, that didn't write very well, 5 times 2 is 10. All right, so you'll say yes, these are equal. So yes, we have a proportion, and they should make the correct shade. So I'm just going to use yes in this particular case. They are proportional. We should get the correct shade. So setting up ratios or proportions or possible proportions and using our cross products can help us to identify the proper information. Now, so we're going to go to the next thing. Instead of just identifying whether things are proportional, is solving using cross products. So basically, two-step problem. One is to cross multiply, okay? Which cross multiply is not technically correct. It's using cross products, okay? But the idea of cross multiply, and that will give you a little equation, and then we're going to solve the equation. Thus, we're going back to things that we did in like chapter 6 and so on to find the missing piece of information. So in this particular case, I have two ratios. We are told they are proportional, therefore they are equal. Again, in this particular case, you probably can tell what the answer is without doing any work. That's fine. We're going to start with a simple proportion, and then we'll work our way up there. So, okay, we're going to use our cross products. So 6 times 10, again, my little butterfly, if you like that, that's 60. Okay, that's my one cross product. That is equal to 3 times p, which is 3p. Now, it doesn't actually matter which order you put these in. If the 3p was over on this side and the 60 was over there, no difference. Okay, so now I'm going to solve my equation. 3 times something is 60. So we would divide both sides by 3. And for some reason, okay, there we go. No, 3. For some reason, my computer locked up for a second, so the 3's reduce themselves out there. And then 60 divided by 3 is 20. And again, in this particular case, I'm sure you probably knew what the answer was ahead of time, but just in case, because there will be ones that are not obvious. Okay, here's a little butterfly, again, for those of you who like the butterfly. Okay, so cross products, and then solve your equation. All right, so now we're going to have to set something up here. So for most people, the ratio of head length to total height is 1 to 7. Now I'm going to go ahead right now, and I'm going to set that up as a fraction, as a ratio. So head length, okay, head, and I'm just writing head here just so I remember what order I put it in. That's supposed to be H-E-A-D, okay, to height is 1 to 7, H-T, I'll just use T. And I'm doing this just to label so I know that I went head over height. So if I keep going here, if a person is 56 inches tall, what should the length of the person's head be? All right, so if I set up this in a proportion, which again I went head length over height, 56 is their height, so that has to go down on the bottom. Okay, so that's going to go down there, which I don't need these labels. I just use them for my organization. How long should the person's head be? I'll use L for the length of their head. All right, I'm going to go ahead in this particular case. Let me change colors here. And I am going to use cross products. Okay, so 7 times L is 7L. And L is just our representation of the length of the head. That is equal to, let's use black, I guess, in this case, 1 times 56, my other cross product, which is 56. All right, so now I have an equation, which I will just simply solve. We undo multiplication with division, so. And since 8 times 7 is 56, it's got to be 8. So the length of the head in this particular case would have to be 8 inches. And so we set up a proportion, used our cross products, and solved our equation to find the missing piece. So, all right, a helicopter used for firefighting travels 25 miles in 20 minutes, which seems to me to be a ratio in itself. So 25 miles in 20 minutes. I'm just going to go ahead and set that right up right now. And again, I went miles over minutes. You could have went minutes over miles. That's okay. The only thing we have to be certain of that if we're setting up a proportion, if I go miles over minutes here, I must go miles over minutes over here. Okay, I got to keep the same order. If I don't, then it messes everything up. So, at this rate of speed, how long will it take the helicopter to reach a fire that is 60 miles away? All right, so I know 60 has to go up here. And I will have some variable. I'm going to use t just because we're talking about time. Not that that's overly important. What variable is not really that important. And I'm going to use my cross products now in this case to solve. So 60 times 20, well 6 times 2 is 12. Tack on my 2 zeros, so that's 1200 equals, and let's try that again. There we go. And then the other cross product is 25t. 25t. And I got a little bit of lag in computer time right here, but we'll do our best. Divide both sides by 25. Okay, again, we're undoing multiplication with division. And so all we're figuring out here is how many times does 25 go into 1200. And so 1200 divided by 25, and you can do this out longhand or in a calculator or whatever. Okay, 48, and this is time, so it will be in minutes in this case. So it should take 48 minutes for this helicopter to make the 60-mile journey. All right, so that gets us to the end of our solving of proportions. And obviously show your work. This is math, we do that. So if you need help, come see me. Good luck.